next determinant for you is if f of x is equal to x plus c1 x plus a x plus a x plus b x plus c2 x plus a x plus b x plus p x plus c3, then show that f is linear in x. Hence deduce that f of 0 is equal to b of b times g of a minus a times g of b upon b minus a, where g of x is equal to c1 minus x into c2 minus x into c3 minus x. ठीक है, that is your question. First question for you, I think it is question number 8, determinant number 8. Okay, let us keep column, first column same. If we subtract column 1 from column 2, we get a minus c1, c2 minus b, 0, and c3 minus c2 if we do 0, a minus c2, c3 minus b. Okay, and then you can split them, x times 1 1 1, column second will continue same, column third will continue same, plus c1 bb, column second and column third will be same. Now this is linear. This will be equal to, say, p times x plus q. Is that okay? Now if you substitute f of opposite of a, what do you get?
Sir?
Yes.
सर त्या px मधले सेकंड आणि थर्ड कॉलम 0 0 0 पाहिजे
का?
सर तरच ऍडिशन येईल बरोबर.
म्हणजे नाही कळलं मला.
म्हणजे आपण जो x ला मल्टिप्लाय करतो त्या मॅट्रिक्सने त्याच्यात 1 1 1 0 0 0 0 0 0 असं सगळे कॉलम.
का? हे दोन असेच ठेवलेत मी.
सर पण मग ते दोनदा नाही काय होणार आणि त्याला परत x ची टर्म पण येईल ना.
अरे x या पहिल्या कॉलम मधनं कॉमन काढलाय. डिटर्मिनंटच्या एका कॉलम मधनं एक कॉमन काढला की तो बाहेर येतो ना, आपण बघितलं मागच्या लेक्चरला.
हो सर कळलं.
हाच बाकी सेम राहणार आहे सगळा. त्यामुळे नाव व्हॉट यू आर सपोज टू डू इज यू हॅव टू आयडेंटिफाय दिस साइड. सो दिस इज एफ ऑफ एक्स. So f of opposite of A is equal to P of opposite of A. Sorry, P of नहीं है. This is P times X. P is a constant. Px, so minus AP plus Q. F of opposite of B minus BP plus Q. So if I want to eliminate Q, or maybe if I want to write down what do we mean by Q, I have to eliminate this. So multiply first equation by B. So B times f of minus A is equal to minus ABP plus BQ, and AF of opposite of B is equal to minus ABP plus AQ. Now if I subtract both, we get Q is equal to BF opposite of A minus AF opposite of B divided by B minus A. This is Q. Now let us find out what is F of opposite of A. Opposite of A is equal to, you have to factorize that. I mean, you have to put these three terms will be 0. F of opposite of A, these three terms will be 0, and therefore F of opposite of A will be the multiplication of these diagonals where you substitute x is equal to opposite of A. So it will be C1 minus A, C2 minus A, C3 minus A. That is F of opposite of A. And what is F of opposite of B? Same. C1 minus B, C2 minus B, C3 minus B. Correct? And you have been given G of X. So F of opposite of A is equal to G of A. And this is G of B. And hence Q is equal to BF of, sorry, B times G of A minus A times G of B upon B minus A. That is what is asked. But what is Q? What is Q? Q is this constant, and constant you will achieve by putting x is equal to 0. So this is equal to f of 0. That is what you were supposed to prove. Is it okay? Question 9. This was 8, then directly 10. Okay. If ABC are positive, and are Pth, Qth, and Rth terms of GP, find log A P1 log B Q1 log C R 1 equals. It is simple. Assume A, B and C in terms of lambda mu. Lambda is first term, mu is common ratio. Put them in place. Then column 3 multiplied by log lambda subtracted from first column gives us this determinant. Log mu is taken out common, and then if we split this determinant, both of them will be 0, hence answer is 0. Next. Evaluate. One, two, three, dot 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 dot, n minus 1, n. 2, 3, 4, n 1. 3, 4, 5, 1, 2. n 1, 2, n minus 2, n minus 1. Is equal to. Let us write A 4 by 4. Okay. What should be our first step? If we subtract third row from fourth, we get 1 here. Second row from third, we get 1 here. First row from second, we get 1 here. So basically n minus 1th row from nth row. So we keep first row as it is. 1, 1, 1, minus 3. 1, 1, minus 3, 1. 1, minus 3, 1, 1. Okay, what is this? N minus 1th row from nth row. That is what is the first thing that we will do. We will keep first row as it is and make everything else n minus 1 row, subtract n minus 1 from n. Now let us make 1 by 4 here. 4, 4, 4, 4. 2, 3, 4, 1, 1 minus 3, 1 minus 3, 1, minus 3, 1, 1. Multiplying first column by 4 and hence 1 by 4 taken out, common. Now what we would like to do is, sorry, maybe before that, gadbad ke liye. We can create few zeros here now. You can subtract first column from remaining columns. 1, 0, 0, minus 4. 2, 0, minus 4, 0. 3, minus 4, 0, 0. This is good. And then 1 by 4, 4 4 4 4 1 0 0 minus 4 2 0 minus 4 0 3 minus 4 0 0. Now what is good about this is if you add all the three columns to the first, you will get what will happen here 1 by 4, 4 as it is, plus 1 plus 2 plus 3, that is 3 into 4 upon 2, that is your first entry. 1 2 3 row wise, second, third and fourth entry, and now what you are doing is adding all of them. So this becomes 0, this becomes 0, this becomes 0, and then 3 by 3 continues to remain as it is. So this is the best possible reduction that you can have, and then after this you have to go for multiplication. So this is equal to 1 by 4 into 4 plus 3 into 4 by 4, 3 into 4 by 2 by, है ना? Okay, this is the first row multiplied by determinant of this. Determinant of this is minus 4 times, it is minus 4 raised to 3. This is the answer for 4 by 4. ओके, सगळे आहेत काय बरोबर माझ्या? Let us do for A3. We know how to do it. Let us do it for A3. One, one, minus two. 1 minus 2, 1. Then we did first column to be subtracted from remaining all columns. First column as it is 1 0 minus 3, 2 minus 3 0. Then multiply by 1 by 3, make it 3 3 3, 1 2 0 minus 3 minus 3 0. Now add remaining columns to first. So 1 by 3, 3 plus 1 plus 2, that is, let me write it as 2 into 3 by 2. That is the entry 1 2 0 0 0 minus 3 minus 3 0, and hence the answer is 1 by 3 into 3 plus 2 into 3 by 2 multiplied by determinant of this is minus 3 raised to 2, but then I think there is a minus sign. This into this minus this into this. So there will be a minus sign here. In this case, there is a minus sign. In this case, this into determinant of this, so plus this minus minus plus, so there will be a positive sign here. So we'll have to decide about that sign, except that the numerical is with us now. So if minus sign has to survive, I don't know how to put it. We have to decide what will come here and what will come here. basically this is going to be positive, this has to be positive, and this has to be negative. Okay, so now you can tell me how do we go about general. Let us try to do it. an would become, by doing first transformation, we will get 1 1 2 3 dot 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 n minus 2 n minus 1. I mean, I'm doing first 1, then you have 0 minus n here, minus n here, diagonal minus n. So we have reached this stage. Everywhere else 0. So which stage are we reaching now? This is equivalent to this. First two transformations. Okay. So after this, what we are going to do is we are going to take 1 upon n out, make first term n, correct, and then let us write it as it is: 1 2 3 n minus 2 n minus 1 complete, minus n as it is. So we have reached this stage. Now what we are going to do is we are going to add all the columns. So we have 1 by n outside, and it is summation of n minus 1 natural number. So n plus n into n minus 1 upon 2, that is the first column. 1 2 3 dot 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 n minus 2 n minus 1 followed by all zeros here. We are writing this matrix now: 0 0, last row 0, and then you have remaining matrix diagonal elements minus n minus n minus n. All these diagonals are, this is not principal diagonal, everywhere else it's 0. Okay, this is what we have. Now actually we can cancel this n over here. So this is equal to 1 over n into n common inside bracket 2 plus n minus 1 upon 2, correct. So this into this is done. Then we have minus 1 raised to something we have to put, and then we have minus n raised to n minus 1. So this is what we have. So only unknown is this, which we should be able to write properly. So one answer which is written with me is
Excuse me, sir.
yes, 1 minute. I will just complete writing, then we will discuss. Minus 1 raised to n into n minus 1 upon 2, that is the power, into n plus 1. I think this is n plus 1 into n raised to n minus 1. Divided by 2. I have this answer with me, and we have reached this stage. So can you finalize that yes, this and this is equal? Yes, Harshita, bolo. Okay. So if I take 4 by 4,
We can do it in 2 steps.
I realize that if I want to change columns into the column such that -5 appears in the principal diagonal, I will have to do so many operations, and eventually I end up getting plus -5 raised to 4 answer of this determinant.
Excuse me, sir.
Yes.
We can do this in two steps also by directly changing C1, C4 and C2, C3.
Yeah, I mean there will be shortcut, but the question, combinatorial question is, if the matrix has size n by n minus 1 by n minus 1, and if you want the odd diagonal to become principal diagonal, how many column flips you have to do? Let us solve that. Here this 4 by 4, when we flipped, we took 6 steps. So actually our n minus 1 is equal to 4. Okay, so n minus 1 is the dimension of this matrix is n minus 1, because we are discussing for capital N, and this particular matrix that we have taken is 1 less than total n. Therefore this comes out to be, the index comes out to be n minus 1 into n minus 2 upon 2, and if we simplify from here to here, plus 1 by 2, so this bracket is gone, this is n by n, so it is gone. Now minus n raised to n minus 1, so minus 1 raised to n minus 1 is again taken out common, which will make it n into n minus 1 by 2, and then n raised to minus. So this is what is our answer. Are you convinced about what we are talking? If I want to change, see, this is combinatorial problem. 1, C1, C2, C3, dot, 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 Cn minus 1. These are the columns that we have. We want them to be changed from here to Cn minus 1, Cn minus 2, dot, 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 C3, C2, C1. Then how many column flips are required? N minus 1 into n minus 2 upon 2. These many column flips are required, and every column flip will give you -1 sign, and therefore -1 raised to n minus 1 into n minus 2 by 2. Once simplified, you get this answer. Now, why do we require n minus 1 into n minus 2 by 2? Is up to you to find out. Okay. Next, Vandermont's determinant VL 1 A1 A2. Simplify and get me the answer. What is this? Let us take V3. 1 A1 A1 square, 1 A2 A2 square, 1 A3 A3 square. We should try to get zeros as many as we can. Therefore, multiplying first column by A3, we subtract it from the second. We are not touching the first column. Multiplied by A3, A1 minus A3, A2 minus A3, 0. Multiply second column by A3 and subtract from third. A1 square minus A1 A3, A2 square minus A2 A3, 0. Okay, this is what we have achieved now, which we can say this is 3 third row first column, so -1 raised to third row first column into determinant A1 minus A3, A1 minus A3 times A1, A2 minus A3, A2 minus A3 times A2. Okay, good. So -1 raised to 4 a1 minus a3, a2 minus a3 common out, and you ended up getting 1 a1 1 a2. So this is Vandermonde 2 by 2 minus 1 raised to 4 a1 minus a3 a2 minus a3 v2, correct? And therefore what we can think of n by n, if we keep doing it like that, then finally we will have to expand using this one, correct? We will get Vn is equal to minus 1 raised to nth row first column n plus 1, right? And then you will observe that all those things come out a1 minus a n, a2 minus an, dot dot dot, an minus 1 minus an. These are the brackets v n minus 1. This will be the recurrence relation for this particular identity. Now, if we want to write down for this, then up to this point it is same. Then we have to say minus 1 raised to n minus 1 plus 1 into a1 minus 1 a2 minus n minus 1 dot 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 up to an minus 2 n minus 1 times vn minus 2. Is that correct? I think so. And therefore the final answer would be, सांगा फायनल आन्सर काय असणार आहे? If I really try to write all the brackets, then Vn would look like, I mean, let me keep this aside, we will figure out finally, but it will be a1 minus an, a2 minus an, dot dot dot, last is an minus 1 minus a. Then I will have a1 minus an minus 1, a2 minus an minus 1, and then last one will be an minus 2, n minus 1. So how many brackets do we have here? N minus 1. First row, how many brackets? N minus 1. Second row, how many brackets? N minus 2. Third row, a1 minus n minus 2, dot dot dot. Second last will be n minus 3 minus n minus 2. This is how many brackets? N minus 3. Correct? Dot dot dot. The last one will be a1 minus a2. How many brackets? 1. 1 bracket. Eventually 1 bracket. So how many total rows do we have? N minus 1. Correct? So what will be the finally? How many total brackets do we have? How many total brackets do we have? 1, 2, 3, 4 up to n minus 1. So n minus 1 into n upon 2. These many brackets do we have? We have got these many brackets. And what do you think therefore will be sign outside this bracket? अरे काय सांगू शकाल तुम्ही की आपलं सोडून देऊया? Okay, if you use factor theorem and substitute a1 in place of a2, determinant becomes 0. a1 in place of a3, determinant becomes 0. And therefore, by factor theorem, a1 minus a2, a1 minus a3, dot dot dot, an minus 1, an is a factor of vn. So, we are trying to write down all those factors, an minus a1, an minus a2, an minus a3, dot dot dot, up to an minus 1, and all the triangular elements are included. So all the brackets, how many brackets? Exactly same as this, which will be n minus 1 into n by 2. These brackets are there. And now let us find out the degree of this polynomial. It is multiplication of principal diagonal. First power is 0, second power is 1, third power is 2, nth power is n minus 1. Therefore, it is n into n minus 1 by 2 degree polynomial. Okay, and we have n into n minus 1 by 2 brackets with us. Therefore, that satisfies as far as polynomial requirement are concerned, but there could be a leading coefficient which is k, leading coefficient, and it is going to be a constant. So, if you look at the coefficient of a n raised to n minus 1, the leading coefficient, then a n raised to n minus 1, this is the highest power term that we will have, and its leading coefficient is 1. एक मिनट, a n raised to n minus. So if leading coefficient of a n raised to n minus 1, so a n, this is the highest power term, and its coefficient is going to be positive 1 because it happens in this diagonal. There will not be any negative quantity, and therefore k is going to be equal to plus 1. Okay, question.